Hi students, Mr. Myers here. Today we're going to go about calculating and finding empirical and molecular formulas. Now to get started, as you can see from the cartoon at the center of the screen, we have this tiger, the C6H12O6, and as you can read, if subscripts in a formula will reduce, it is not an empirical formula. So that gives us some insight then to what an empirical formula is. The empirical formula expresses the simplest whole number ratio of ions in a formula unit, or the simplest whole number ratio of atoms of each element in a molecule. So basically, how the atoms are arranged in a formula, if it's the simplest whole number ratio of those atoms, or of those elements, then it's the empirical formula. The molecular formula we'll get to in a little bit. So let's see how we go about finding the empirical formula. I've created a flow chart that hopefully will help navigate your way through it. First, you're given the mass percent of elements. This is the percent composition that we had in a previous video. From there, we assume that we have a 100 gram sample that we're working with, because if we have percent composition, those mass percents, we can just change them into grams. So now we have the grams of each element. From there, we're going to divide by the molar mass of that element. What that does, and as we'll see on the next slide, is it'll give us the moles of that element. Okay? And now we have maybe several elements we're working with for our formula. We don't know the formula yet, but we know how many moles there are of each. Well, what we need to do is create a mole ratio between them. And to do that, we're going to divide each value by the smallest number we found. That ratio is then going to give us the empirical formula. Okay? So if you need to pause for a moment, jot down this screenshot or jot down this flow chart here to help you, go ahead. Otherwise, we'll go ahead and get started on a problem. We need to calculate the empirical formula of caffeine given the following percent composition. We're given 49.5% carbon, 5.15% hydrogen, 28.9% nitrogen, and 16.5% oxygen. First, we'll look at carbon. If we take the grams of carbon, assuming it's a 100 gram sample, so our percent becomes grams, we're going to divide by its molar mass. This gives us 4.12 moles of carbon. Now let's repeat the process with the other three elements. Doing so with hydrogen will give us 5.1 moles of hydrogen. 28.9 grams of nitrogen leads to 2.06 moles of nitrogen. And for oxygen, we have 16.5 grams of that, divided by its molar mass, 1.03 moles of oxygen. So we're at that part in the flow chart you saw where we now have the moles of each, and we need to set up a mole ratio. To do so, we are going to divide all of these by the smallest number present. The smallest number here is the moles of oxygen. So I'm going to come over, and we're going to divide everything by that value, 1.03. We're going to do this for everything. So this one comes out to 1. This comes out to 2. This up here for carbon is going to come out to 4. And this one over here, I have a sheet here, is divided by 1.03. This is going to give us 4.95, which, if you are close enough to a whole number, go ahead and round. So this is going to be 5. So if we set that up with our atoms, we have C4, H5, N2, and then O1, which we don't need to write the 1 because it's implied. So this here is our empirical formula. Now, one thing I do want to mention is over here with hydrogen we had 4.95 moles for the ratio, which we said round up. If you ever come into a situation where you have about 0.5 or maybe 0.45 or 0.55, somewhere where it's close to half, never round up or round down. Instead, you're going to multiply everything by 2 to give you that whole number right there. Right? So these were some tips and some calculations we went through to find the empirical formula. Now let's look at a molecular formula example. So for molecular formulas, this is the multiple of the empirical formula. Okay? Or again, as it says, the molecular formula of a compound, it's some multiple of the empirical formula. Now, in order to determine the molecular formula, you need a few things. First, we need the empirical formula. From the empirical formula, we can find out its molar mass. And then we also need to know the molar mass of the molecular formula. And through all that, we'll find out the molecular formula. Let's take a look. We just found the empirical formula of caffeine to be C4H5N2O. If the molar mass of caffeine is 194.19 grams per mole, find the actual molecular formula for caffeine. To go about this, we said that the molecular formula is some multiple of the empirical formula. So for calculation purposes, we're going to take the molar mass of the molecular formula, which is given here in the problem, and we're going to divide it by the molar mass of the empirical formula, which means the empirical formula we found above, or previously, we need to find its molar mass. And that will give us some number, let's say n, where then our molecular formula is some multiple of the empirical formula as shown. For math purposes, we'll take the molar mass of the molecular formula up above, 194.19, and divide it by the molar mass of the empirical formula, which I already found for you, 97.11 grams per mole. The calculator spits out this long number, which is really close to the number 2. So we can round it to 2. So we take our empirical formula here. We're going to multiply all of the subscripts by that value of n, which is 2. And what we would get from this is C8H10N4O2. So C8H10N4O2. And that's how you go about finding the molecular formula.